So when we add and subtract radicals, there is a rule that we have to follow, and that is we can only add them if they have the same index and also the same radicand, meaning the number under the radical sign has to be the same as well as the index. If they are not the same, you can't add or subtract them. You would just have to leave them as they are. Sometimes they're not the same, and we can simplify them, and then that turns them into the same thing so that we can then combine them. So if I take a look at number 1, we'll start real easy. 2 square roots of 7 plus 3 square roots of 7. Do I have the same index and same radicand? Yes. So I can add these together, and all I do is I add the coefficients. So basically just do 2 plus 3, which gives me 5, and that square root of 7 is going to stay the same. Okay, we don't change the number under the radical. We don't add it. It stays the same just like a variable would if I was adding 2x plus 3x. And then most of the time they'll already be simplified if you've gotten them to the point where you can add them together. However, we just still want to check and make sure. So can I simplify the square root of 7 at all? Does it have a perfect square in it or not? No. So then we would just leave our answer. Now on number 2, I have 3 square roots of 2 plus the square root of 8. Do I have the same radicand now?
No.
No. So what I need to do is see if either of them or both of them can simplify and hopes that it turns them into the same. So let's start with the square root of 2. Can we simplify the square root of 2? No. What about the square root of 8? Yes, that one can simplify. So I'm going to take it and I'm going to split it up. It breaks down into the square root of 4 times the square root of 2. The square root of 4 turns into 2. And then I'm just going to bring that first one down since I didn't need to simplify it. Are they the same now? Yeah. Yes. So we can add them together. And again, we're going to just add the coefficients. What is 3 plus 2? 5. And then that square root of 2 stays the same. Square root of 2 we already talked about cannot simplify. So that is how we leave our answer. Make a little bit of sense? Okay. All right. Try number 3. We got 2 square roots of 45 minus 6 square roots of 5. So simplify one or both, whichever can happen. Start with the 2 square roots of 45. Does 45 have a perfect square in it that we can simplify? Yes. Yes, so you need to work on that first. Then you look at the second term. That is 6 square roots of 5. Does the square root of 5 simplify? No, so that one's going to stay the same. What perfect square goes into 45? 9. So we're going to hang on to that 2 for now. Maybe. We're going to split 45 up into the square root of 9 times the square root of 5. Square root of 9 turns to 3, which is going to give me 6 square roots of 5. And you said that second one doesn't simplify, so I'm going to bring that down. Do we have the same radicand now? So we're going to do the coefficients. What is 6 minus 6? 0. Okay. One thing I need to mention is because this happens quite often in a problem like this. 0 means 0 square roots of 5, so the answer is just 0. Okay. If you put the square root of 5, what number is technically in front of that? A 1. Okay. I'm trying to write it. It's not letting me. You just told me that 6 minus 6 was 0, but if I put the square root of 5, that says that it is 1, right? So make sure that when you do something like this, if they subtract and give you 0, you do not put the radical on it, because then that would give you 1 square root of 5. Now, if you put 0 square root of 5, yes, that's technically correct, but you can also just put 0. Everybody okay with that one? All right, number 4, I have 5 cube roots of 3 plus 8 cube roots of 3. Is my radicand and my index the same? Yes. So I can go ahead and do the work. 5 plus 8 is 13. And that cube root of 3 is going to stay the same. And then I just check, can I simplify the cube root of 3? Is everybody okay? All right, I would like for you to try both of those. Simplify both terms in number 5. Okay, neither of those are perfect cubes as they sit, but they can be simplified. And then the same thing with number 6. You're going to need to simplify both of those. Those are square roots. Make sure you're looking at the proper column in your chart when you're trying to simplify. Hopefully when you simplify them, they will turn out the same so that you can actually bring them together. Is 54 a perfect cube? Is it on my list?
No.
No. Okay, so we're starting with the one closest to it without going over. Does 27 go into 54? Yes, it does. How many times? 2. So we're going to split that into the cube root of 27 times the cube root of 2, which turns to 3 cube roots of 2. And then 16. Is 16 a perfect cube? No, but what perfect cube goes into 16? 8. So we're going to split that into the cube root of 8 times the cube root of 2. And that's going to turn into 2 cube roots of 2. Do I have the same index and radicand now? Yes. And so we can just do the front part. What is 3 minus 2? 1. So this one should be just a 1 cube root of 2. You can put the 1 in front if you want, but you do not have to. With number 6, I got the square root of 48 and the square root of 12. Can I actually subtract those right now? Are they the same? No. So what we're going to have to do is simplify them. What perfect square goes into 48? We'll start with 36. Does that go in? 25? 16? How many times? 3. So we'll break that down into the square root of 16 times the square root of 3, which gives me 4 square roots of 3. Then I'll do the 12. That breaks down into the square root of 4 times the square root of 3, which is 2 square roots of 3. Are they the same now? Yes. What is 4 minus 2? 2. So it's 2 square roots of 3. Is everybody kind of okay with that one? Ooh, toss up. Same thing, just a little bit longer. It's got 3 terms instead of 2. Simplify each term first as much as you can, and then we'll talk about putting them together. Start with the 8 square roots of 12. Look at 12. It's not a perfect square. See what perfect square divides into it. Simplify all that. Then do the 2 square roots of 75. Then do the 3 square roots of 28. What perfect square goes into 12? So I'm going to keep the 8 in the front. I'm going to split that up into the square root of 4 times the square root of 3. That turns to 8 times 2 square roots of 3, which gives me 16 square roots of 3 for the first part. Are you okay with that? All right. 75 is not a perfect square. What perfect square goes into 75? 25. So I'm going to keep the 2. I'm going to split that up into the square root of 25 times the square root of 3, which gives me 2 times 5 times the square root of 3, which gives me 10 square roots of 3. And if you notice, I just brought down that negative sign with it. I didn't really do anything with that just yet. And then we're going to do the same thing with the 28. 28 is not a perfect square. What perfect square goes into 28? 4 times 7. So that turns into 3 times 2 times the square root of 7, which gives me 6 square roots of 7. Are they all three the same? No. Don't have any of them that are the same. Yes. So I can combine the ones that are the same. The one that is not is just going to have to come down, and we will end up with 2 terms instead of 1. So I'm going to do the square roots of 3. 16, maybe. 16 minus 10 is 6 square roots of 3. And then because I cannot put that square root of 7 with it, I just bring it down, and I leave my answer just like that. So if they are not the same, they cannot be added or subtracted. You just leave them as a polynomial. Okay, come with the terms you need to that can't be combined. Any questions on that one? All right, we're going to continue to do the same thing, but we're going to throw some variables in now. Because it changes just a little bit with variables, we have to be more careful with what we're doing. So if you will take a minute, write 8 down. We'll do this one together. I've got the cube root of 8x to the 4th y to the 6th. And then I've got the cube root of 27x to the 4th y to the 6th. So let's work on simplifying the first one. Let's work on simplifying the cube root of 8x to the 4th y to the 6th. And kind of like we did day before yesterday when we were doing these, we're going to just split them apart and deal with each piece individually. So we'll start with the cube root of 8, maybe. And then we'll do the cube root of x to the 4th, and we will do the cube root of y to the 6th. Starting with 8, is 8 a perfect cube? Yes, so that's just going to turn into 2. And then remember, for our variables, we look at the index, we're doing the x. How many times does 3 divide into 4? 1 time. Any leftovers? 1, right? Then we can do the y's. How many times does 3 divide into 6? Twice. Any leftovers? No. Now let's put all of that back together. We're going to multiply everything that is not under the radical. So we're going to multiply the 2, the x, and the y squared. And then that radical is just going to come sit behind that. So that first term simplifies to be 2xy squared times the cube root of x. Now I want to do the same thing with that second piece. I'm going to split it apart first so that I can simplify. Is 27 a perfect cube? Yes, that turns to 3. Then we do our x's again. How many times does 3 fit into 4? Once with 1 left over. And then how many times does 3 fit into 6? 2 times with no leftovers. Again, we're going to multiply everything that is not under the radical symbol together. Maybe. I'm going to bring down my plus sign too. So that's going to give me 3xy squared times the cube root of x. Now, because we have variables, not only does the index and the radicand have to be the same, but the variables in front of it have to be exactly the same as well. Remember, with variables, we can't add them if they don't have exactly the same exponents and exactly the same variables, right? So do I have exactly the same exponents and variables in the front? Yes, I have an xy squared in the front of both of those. And then my radical is the cube root of x on both of them, so they are also the same. So I can continue to add these. If any of those exponents had changed and they were different, that's about as far as we could take it. But because they're the same, we can add them. What is 2 plus 3? 5. So we're going to get 5. And then everything else is going to stay the same. 5x squared, 5xy squared times the cube root of x would be my final answer there. Again, if that x in the first one had a different exponent besides 1, we would not be able to add them. But because they were the same, we can. I want you to try 9. It's our last one. Simplify each piece individually. Then see if you can add them by making sure all of the variables have exactly the same exponents and everything else looks the same as well. So like if you had just 2x and 2x, you would change the exponent when it multiplies. All right, is 16 a perfect square? Yes, okay, so that's 4. And then for the x, 2 fits into 2 how many times? 1. Any leftovers? No. Okay. And then for the y, 2 fits into 5 how many times? Twice, with how many leftovers? 1. So if I put all that together, I get 4xy squared times the square root of y. Does everybody agree with that? Okay. Then I'm going to do the next part. What's the square root of 4? 2. All right, and then for the x, 2 fits into 4 2 times. Any leftovers? No. And then for the y, 2 fits into 3 1 time with 1 leftover. And everything that's not under the radical gets multiplied together, 2x squared and y. And then that radical just sits behind it. So I'll have 4xy squared times the square root of y plus 2x squared y times the square root of y. Are all of my variables exactly the same with the same exponents? No. So can I actually add those together any further? No. So we just leave our answer like that. And just be real careful with the variables. Make sure they're the same before you start adding them together. Anybody have any questions? Okay, that worksheet I gave you is your homework. Remember, we are on pep rally schedule, so we get out of here at 8:15.